I would like to welcome y'all once again to this month's Wildlife for Lunch webinar. Today's webinar is on aquatic plant identification and control options, presented by Dr. Todd Sink, Assistant Professor and Fisheries Specialist with Texas A&M AgriLife Extension. Today's webinar is made possible through funding provided by the San Antonio Livestock Exposition Incorporated, and it's hosted by the Texas Wildlife Association and Texas A&M AgriLife Extension. With that, Todd, you should now have the controls.
Alrighty. Well, howdy and welcome to the presentation today. I apologize. I'm a little under the weather, so my voice is going to be a little weird throughout this presentation. But let's go ahead and get started. And I'm going to cover a lot of information today and talk a whole lot. And I don't expect anyone to be able to remember everything that I covered. So I want to start off by pointing you to some important resources where you can find this information covered today and much, much more. The first one at the top is the Aquaplant website. It's just Aquaplant, all one word, .tamu.edu. If you have any question that is aquatic vegetation management related, what is it? Is it good for fish or wildlife? How can I propagate it? Is it invasive? How do I treat it? Those types of questions can all be found on the Aquaplant website. So the second resource down below is the Aquaculture, Fisheries, and Pond Management website. It's just real simple, fisheries.tamu.edu. This website does have some aquatic vegetation management information on it, but in general, this is the website where you go if you have a question about anything else pond related. We have tons of resources on there on stocking fish, sealing leaking ponds, managing fish populations, aquaculture. So there's a lot of very, very good resources, not only from Texas A&M, but from universities and government agencies throughout the southeastern U.S. and I guess the entire country as well. Now, for those of you that I know it's oftentimes difficult to identify a plant because we normally run across it unexpectedly in the field, and so we don't necessarily have a ID guide right there with us. We have made a couple of apps that you can download to your smartphone that have nice picture identification guides. The first one is Aquaplant. It is essentially most of the information that you'll find on the Aquaplant website, but it is more of a cell phone user-friendly format. You can move through the information a lot quicker. It's organized more efficiently. The second app down below is Aquacide. It simply just shows you a picture ID guide so that you can quickly identify the plant you're looking at, and then it shows you the best ways to manage that plant. All right. So in the past when I've done these presentations, we normally go through aquatic vegetation ecology and the reasons why they're so invasive and all of that different information. And it seems like I almost never have time to get through managing the specific species. So we're going to jump right in today, and we're going to start with the most important step in aquatic vegetation management, and that's identification. If you don't identify what you're looking or what you're attempting to manage, you're going to have some real problems with the management itself. For example, there are only 14 aquatically approved herbicides, and there's not a single one that treats every species of aquatic vegetation. Most ponds typically have a mixture of vegetation that often requires 2 or more different types of herbicide in order to use. And so if you don't identify it and you just go out and buy something, there's a high probability it won't work on the particular species you're trying to manage, and you'll end up not only wasting the money for that treatment, but you'll also be going to buy herbicide again once you figure out the correct one. Now, I am not an aquatic botanist. I'm not really a fan of plants. Went to school for fisheries, but fisheries is something we have, aquatic vegetation is something that we just have to deal with and learn to manage in fisheries. And so I don't expect any of you to become aquatic botanists. What I really want you to be able to do is to be able to group your vegetation into one of 4 categories. And the reason I want you to do this is, first of all, you'll be miles ahead of most people in terms of managing your aquatic vegetation, but also because if you can get it into one of these 4 groups, typically the management for that group is very similar, and so a lot of the options will work across many species for that group. Now, the 4 groups that we're going to discuss today, and I realize there are 5 here, but the first is algae, the second is floating, the third is submerged, and then we generally combine the last 2, emergent and shoreline, because they're typically the same species, and so we typically lump those together under emergent species. So, when it comes to aquatic plant identification, the first group, algae, what you need to remember are they are primitive, non-seed-bearing plants, and they have no roots, stems, or true leaves. Now, some of them, the macroalgae actually look like vascular vegetation growing in your pond. But the important thing to remember is if you reach down and pull it up, it will not have any roots. Many of them also look like they're branched with leaves. However, in those cases, if you simply take one of those leaflets and roll it between your fingers while applying pressure, it will pop, because it's not a true leaf, it's just a group of enlarged cells. The next group of aquatic vegetation is floating, and this one's real simple. It means all parts of the plant floats. And so one issue that we typically find is that most people consider water lilies and lotus and spatterdock to be floating plants. Well, that's not the case at all, because they're rooted to the bottom, or I'm sorry, they have a long stem going to the bottom where they have an extremely large root, and the majority of their plant biomass is actually under the water surface. So when we talk about floating, all parts of the plant float. You should be able to take your hand and go completely underneath the plant and not contact anything going down to the pond bottom. Submerged. Submerged plants are mostly underwater, they're rooted, and they have flaccid stems. So the rooted is important because that's how we're going to differentiate them from algae, especially those macroalgae. And the flaccid stems is important because that's how we're going to distinguish them from the emergent vegetation. So what do we mean by flaccid stems? Well, if you see a plant in the water and you're not sure what category it's in, reach down, grab it by the base, pull it up, and if it's able to hold itself erect, then it's not an emergent. Or I'm sorry, it's not an submerged. If it falls over limp, it's unable to support its weight, well then it's a submerged species. As we kind of just alluded to here, the next category is emergent, and so this category has stiff or rigid stems with parts standing above the surface. And so that last distinction, parts standing above the surface, is you kind of have to take that with a grain of salt. Because what do our water levels in our ponds do in Texas during the year? They fluctuate quite a bit, right? So during the summer, we have a lot of evaporation. The pond might drop a couple of feet. During the spring, we might have extremely heavy rains. And so emergent plants can actually be found standing several hundred yards away from a pond. As long as the soil is moist enough, they'll survive. Or they can be found completely submerged under the water. So in these cases, what do? You reach down by the base, you pick it up, and an emergent plant will have a stiff or rigid stem, so it will be able to hold itself erect or upright. And so those are the four basic component or categories, and I think that most people can now get their aquatic vegetation into one of these four categories. Now, before we jump into the plant identification, we list herbicide treatments with each one of the plants. And real quickly, I want to walk you through the different herbicide classifications so that you understand what I'm referring to when we're making recommendations. The first classification is contact herbicides. These are herbicides that cause immediate cell damage at the point of contact, but it also means that they must come in direct contact with the plant within a short period of application. They tend to be extremely fast-acting. Some issues with contact herbicides is that they're only going to kill the tissue that's above the ground. In other words, if they don't come in contact with the root because it's below the soil, it's not going to kill the root. You're going to kill the vegetation back, but there can still be roots there where the vegetation can resprout and come back. Contact herbicides, therefore, are typically used on annual species, and they're often an annual treatment required because the plant does come back. The approved contact herbicides are copper-based herbicides and algicides, diquat, indethol, flumioxazine, and sodium carbonate pentahydrate. Okay. Now, in terms of our systemic herbicides, these are herbicides that translocate throughout the plant. In other words, we typically have to bring these to a particular concentration throughout the entire water body, and the plants gradually take them up over time, and they're translocated around to the roots and any tubers and all the different types of parts of the plant so that you get a full and complete kill of the plant. Systemic herbicides are typically slow-acting. Some of our ones that we use to manage ponds, oftentimes we won't see any type of noticeable effect until 6 to 8 weeks after application. Systemic herbicides also result in total plant mortality, and that means that oftentimes they're your best chance to eradicate the species from a pond. And so we typically use systemic herbicides on perennial and woody species. The approved herbicides systemic herbicides for aquatic use are fluridone, triclopyr, imazapyr, imazamox, and bispyruvic sodium. There's also another one that is listed down below here, glyphosate. Glyphosate is technically a systemic, but it's what we call a fast-acting systemic. And so we tend to place it more with our contact herbicides. The reason why we consider it a fast-acting systemic is because on most of the aquatic species that you would be using it for, typically you're going to see plant death and mortality within 4 to 7 days. So it's going to have a pretty immediate effect on that vegetation. So, moving into our first category here, algae. Well, there's planktonic algae. These are the microscopic tiny floating algae. They're single-celled organisms. You can't see them, so basically you can scoop up a handful of water and they just run between your fingers. You can't see the individual cells. These are what give your water that kind of greenish tint to it. And planktonic algae is actually very good. It is the basis of your entire pond's food chain. And so it feeds everything from the insects and the detritivores to all your larval fish in the pond. And so we typically don't want to treat planktonic algae unless it becomes extremely excessive. The next category is filamentous. Filamentous is stringy or hair-like. It grows in long strands, and often we see it form these large mats. And then the last category are macroalgae. And so these are the ones that tend to look like rooted vascular vegetation, although they're not. And so the two genera that we typically see in Texas are Cara and Nitella. Cara is much more predominant in Texas. So, the first one that we're going to cover today, and I'm going to spend a lot of time on this plant species because it is by far the #1 most problematic plant in Texas. I receive 70% of my aquatic vegetation calls are about filamentous algae. Filamentous algae is nasty stuff because, you know, it hinders our recreational activities. I know many of you have been to that pond where you cast out your lure and you make 2 cranks of the reel handle before you have to reel it the rest of the way in and clear out 5 pounds of muck. Trying to swim through it is not very fun. You kind of come out looking like swamp thing. And unfortunately, none of our pond species eat it, so there's no direct consumption or benefit to any of our fish in the pond. So, in order to treat algae, what we're looking at are chelated copper complexes, diquat, or copper sulfate as your main treatments. Now, we'll start with copper sulfate. It's also sometimes called bluestone. It's a solid crystalline granular that is blue in color. And so it is the most common aquatic herbicide that you will find anywhere. And there's a reason for that. It's not because it's the best. It's because it's the one aquatic herbicide we have that is actually a solid that is stable for long periods. So if you run a small feed store and you don't sell a lot of herbicides, well, you can buy a pallet of this stuff in 1980, and it's just as good today as it was in 1980. Okay? Now, I'm sorry, I was turning up the volume. I'm seeing some things going on about people can't hear me, and hopefully everyone can hear me a little better now. Now, so the reason why copper sulfate is not always terribly effective is that most people use it incorrectly. Copper is a contact herbicide, which means it has to come into direct contact with the plant tissue in order to kill it. And so when you buy it, it's in this solid crystalline form, and so what happens to it when you throw it into the pond? Well, it quickly sinks to the bottom. Copper is a heavy metal, so it naturally sinks in water, and so the copper ion never really enters the water to come in contact with any of the vegetation you're trying to treat. And so what you actually have to do is you have to dissolve it in warm water first and then spray it out over the top of the algae in order for it to be effective. That's one of the many reasons why we prefer to use chelated copper complexes. Chelated copper complexes have a lot of advantages in that, one, they already come in a liquid form, so you don't have to mix them. You basically pour them in your sprayer, add an appropriate amount of water to dilute, and spray. Two is that they are much, much safer for your fish. Of all the 14 aquatically approved herbicides that we'll talk about today, there's only one that even comes close to being toxic to fish when used at the correct labeled concentrations. Copper, in order to be effective on algae, needs to be applied at about 0.8 to 1 part per million in order to be effective on filamentous algae. The issue is that at about 1 part per million and above, it can start to become toxic to some of your fish species. And so what we see is people oftentimes overestimate the volume of their pond, and so they end up putting out a greater concentration than what you should actually have in the water. So it's really important to make sure you have good knowledge of the volume of your pond, the pond depth, before applying. Chelated copper complexes are actually much, much safer for fish than copper sulfate, and so it gives you that room for that oops factor of over-calculating. Typically, chelated copper complexes are safe up to the 3 to 4 part per million range, so that's quite a good buffer zone for you. Another advantage of chelated copper complexes is because they are chelated, they stay in suspension in the water column for much, much longer. And so that means they're out there floating around, able to come into contact with more algal cells and give you a much, much more thorough kill. Copper sulfate is going to remain, the copper ion is going to remain in the water for anywhere from 1 to 3 hours, whereas with chelated copper complexes, you may get between 4 and 8 hours of the ion remaining in the water, killing the algae. The next one we have here is diclot. Diclot can be effective on some species of filamentous algae when used on its own. However, what we normally do is we tank mix diclot with chelated copper complexes or copper sulfate and then apply it together. The reason why is because these two different herbicides have different modes of action, and their combined effect is much greater than either one on its own. And so, therefore, it's such a good combination that diclot comes specifically labeled for mixture with copper sulfate or chelated copper complexes. There's directions right on the label. And so what generally happens is by mixing these two herbicides, we can use the lowest labeled rate of the copper algicide, the lowest labeled rate of the diclot herbicide, and get a more effective kill than we could either using the copper or the diclot alone at its maximum labeled rate. And so we actually end up using less herbicide overall and getting a more effective kill by doing tank mix. Now, the last thing I have down there is Mozambique tilapia. And the reason I have Mozambique tilapia on here is not because they are an effective management tool for filamentous algae. It's to caution you that they are not. And so part of the issue stems from most people do not understand that tilapia is actually a common name applied to a group of around 300 fish species across 3 different genera. And so some of those species are very effective. They consume large quantities of filamentous algae, and so that's kind of how tilapia got its reputation as being a viable treatment for filamentous algae. However, in Texas, we're only allowed to have 3 species in the state, and of those 3 species, there's only 1 species that we're allowed to stock in outdoor ponds, and that's the Mozambique tilapia. The issue is Mozambique tilapia is not one of those species that consumes a large portion of filamentous algae as part of its diet. And so they're not real effective at eliminating algae. Now, does that mean you shouldn't use them? Well, no, that's not necessarily true. They do consume about or up to 10% of their diet is filamentous algae. The issue is that when you stock them and you have a severe algae problem, the algae reproduces much faster than they could ever consume it. And so if you're going to go with the tilapia option, you first need to go in and use a good herbicide treatment such as chelated copper complex or copper plus diquat. Knock the majority of the algae back, then stock your tilapia and allow them to begin to graze on any new regrowth. And therefore they can get the issue a little bit better in hand. Now, Mozambique tilapia do die off once the water temperature drops below 50 degrees, so in many parts of the state you do have to restock them every spring. Sometimes in mild winters you do get some carryover, and if you're waiting until you see mats of filamentous algae or midsummer, it's really too late to stock tilapia by that point. You need to begin stocking tilapia in the spring as soon as the water temperatures are warm enough, because they have to continuously reproduce and multiply to produce lots and lots of offspring in order to be able to consume enough algae to make a difference. Now, another issue with Mozambique tilapia is that if you have largemouth bass in the pond, they're really not effective because the largemouth bass population are very effective predators on their offspring, and so they can't reproduce quickly. And so that means you'll have to stock many, many, many more adults, which are quite expensive to stock on their own. And so that, let's see here. Hang on, I've got one final thing on filamentous algae. This is what filamentous algae actually looks like when it's alive and growing. It is a deep green color. Sometimes it can almost be like a dark lime color. But as you can see in this picture, as he's pulling it apart, it's very tough and gritty. It feels kind of like what caught it. And it's not that kind of mushy stuff that you see at the surface. The reason for that is this is filamentous algae from the bottom. And if we look back to our previous picture real quick, down here in the bottom left, you'll see the filamentous algae growing down along the bottom. That's how filamentous algae normally grows. It grows as a carpet over the bottom or over other vegetation. Oftentimes, once the weather starts to become warm, typically in May, June, I start getting a lot of calls from people saying, well, I've suddenly got a filamentous algae problem in my pond, because they start seeing these kind of floating light lime green mats on the water. And the issue is, no, you had a filamentous algae problem during the spring, and now it's dying off, and that's why you're getting these big mats of it. If you look at the mats, you'll notice that they are a lighter yellow-green, and that is because they are actually dying and being bleached out by the sun. They're no longer producing chlorophyll. Filamentous algae likes to grow in cool weather, and oftentimes it becomes very stressed and begins to die off during the summer. All that dead and dying biomass, because it is so stringy, as it decomposes, begins to trap gas bubbles in it. And you can see how these surface mats look really bubbly. And that's because it has trapped gases both from decomposition and plus oxygen from any living algae down below it, makes it float. And so when you go to try to pick up that surface mat, it will like just run through your fingers. You know, it's not tough, it's not stringy, it's kind of really gross and slimy. That's dead and dying stuff. And so if you're waiting till this point to treat, it's actually problematic because the surface mats will actually prevent your contact herbicides from getting down to and coming in contact with the living algae below it. And so typically if you have a pond historically year after year has filamentous algae issues, you actually want to go out and begin treating in the spring as soon as the water temperatures warm to between 60 and 65 degrees. That way you're killing those filamentous algae mats along the bottom, and if you do so, oftentimes you can have an algae-free pond all summer long. Now, I'm not going to say that's a guarantee. Sometimes you do have to go back and do spot treatments for areas that you missed, and sometimes very fertile water, filamentous algae will come back quickly, but it's going to be much less and it's going to be more manageable. So I think I've talked about as much as I should about filamentous algae, and so now we'll move on to some other species. This next species, this is Cara. It's also known as skunk grass, and if anyone has picked this species up and rolled it between their fingers, you will understand why it's called skunk grass. Your hand will literally smell just like a skunk's butt. It has a very, very strong skunk odor. And another thing is when you basically pinch it and roll it between your fingers, you'll get that odor, but it also feels coarse, like there's grits of sand within the plant itself. And that's because it actually takes calcium carbonate out of the water and begins to form these little calcium nodules throughout the tissue. So this is an algae. So it might look like a vascular plant, but when you reach down and pick it up, you'll find it doesn't have any roots. And because it is an algae, we're going to use our chelated copper complexes or copper sulfate to treat it. Now on these macroalgae such as Cara, diclot is not that effective, so we don't recommend diclot on its own. The only time you would use diclot on Cara is when you're using it in combination with chelated copper complexes or copper sulfate. Moving on to our next category here, floating plants. And I apologize, I thought I did away with all these animations, so I will click through them quickly. And so some of the species we're going to cover today include the duckweeds, watermeal, Azolla, salvinia, water lettuce, and water hyacinth. First, let's start off with our duckweed and watermeal. And the reason we kind of cover these two together is most people can't tell the difference. The primary difference that you'll see is if you have them side by side, watermeal on the right is much smaller than duckweed on the left. However, if you don't have them directly side by side for size comparison, you wouldn't necessarily know that. And the key to telling them apart is if you look at the line diagrams of the duckweed in the upper left corner there, all duckweed species have one to multiple roots hanging down from it. So if you pick it up and you see little roots hanging down, you have a duckweed. On the other hand, if you look at the watermeal, they're nothing more than little round green discs. You won't find any roots hanging down from them. Now, these two species are very problematic in that watermeal is the smallest seed-bearing plant on Earth. Each one of those little discs can produce up to 20 seeds per month, each month during the warm growing season. And there can literally be hundreds of millions of these plants on a single acre of water. And so they're creating this enormous seed bed. Well, the issue is if we go out and say use a herbicide on it, well, the herbicides don't work on the seeds. So you'll kill back the adult population, but oftentimes you come back out 2 or 3 weeks later and it looks like you never even applied. And so what we typically do then to manage these species is we need to use long-acting systemic herbicides. These are ones that stay present in the water for long periods. And so these include carfentrazone, fluridone, or pinoxylum. All three of those are extremely expensive. Just for an example, fluridone starts at around $1,800 to $2,200 per acre, while carfentrazone can run you from $2,500 to $3,200 per acre, depending on the treatment, the treatment strength that you need to apply. So many people balk at the price and they choose to use a contact herbicide. And flumioxazine, that's listed here in the middle, flumioxazine is the main contact herbicide you would use. The issue is if you're using a contact herbicide, you're only killing the adult plants, the seedbed comes back. However, fluridone, which is the one that I most commonly recommend for these species, can remain active in the water for up to 12 months. So not only does it kill the adult plants, but it continues to kill the seeds as they sprout, giving you a clear pond. Also, by using fluridone or carfentrazone in repeated years, that's actually your best chance of eradicating these plant species from your pond permanently. It is difficult to do, but it can be done, and you have to keep up with the treatment. Now, flumioxazine, on the other hand, is a contact herbicide, and so when you spray, we typically, it's very difficult to get all of these cells because they are so small, and the herbicide itself has to come into contact with each and every one of these plants in order to kill it. So oftentimes what we need to do is come in and do one large main treatment, wait 10 to 14 days, and then come in and start doing these little spot treatments in areas where you continue to find it. And you need to keep up with that for several months during the summer period, warm growing season, so that it doesn't come back immediately and reinfest and totally cover your pond. Now, I do have some biological controls listed down here. Both tilapia and ducks, and I have listed here that they do both have other issues. For one, duckweed did get its name because ducks do love to eat it, and so they will consume large quantities of it. But someone actually did a study on how much duckweed a duck could eat a day. And so based on that study and the amount of duckweed a duck can eat and the amount of duckweed that can cover a 1-acre pond, it would take approximately 287 ducks to effectively manage 1 acre of duckweed. So having that many ducks on a pond is typically problematic because ducks tend to disappear when they're at high densities. You have wildlife predators, you have the neighbor's dog, sometimes depending on how mean they are, the neighbor's kids. You know, ducks just tend to not be able to maintain those high densities on the pond. Also, they're constantly stirring the water with their dabbling, which can make your pond muddy. Finally, no one wants to walk through all that duck food to go down to the water and fish. Now, tilapia, on the other hand, we can add tilapia, and tilapia do consume both of these species. They're moderately effective, but if you do have a situation where you say you have a pond, a 1-acre pond that's perhaps 1/4 to 1/2 covered with duckweed or watermeal, the tilapia just simply won't be able to keep up by eating the amount of biomass that's out there. And so for both tilapia and ducks, what we recommend is you again, go with an integrated management strategy. Go out and treat with your flumioxazine, a lower cost contact herbicide, to knock the majority of the population back, and then stock your tilapia or a lower number of ducks. Typically, you can get by with 10 to 15 per acre. And what they do is they then raise off the new plants as they begin to sprout from the seeds. And so in that way, you can get effective management or control of the situation. Our next species is Azolla, more commonly known as Mosquito Fern. Oftentimes during the fall, I begin to get calls about people, and they're typically very upset and concerned. They notice that the vegetation in their pond suddenly changed from green to red, and they just about always think that it's a toxin being produced. I can assure you that whenever I hear that, that is not the case. I know right away that you have Azolla. Azolla is a true aquatic fern that is typically green, but Azolla does not like cold weather. It's a really warm weather species. And so when it begins to cool in the fall, it gets really stressed. And its natural response to stress is to stop producing chlorophyll, which gives it the green pigment naturally. Well, the underlying pigment below that chlorophyll is mainly red. And so you get this kind of rust red brown look of floating vegetation around the water. Now, cows have been known to eat this, as you can see from the picture there. I actually think that cow is personally just getting a drink, but cows are known to eat it because it is extremely high in protein. It's about 32% protein. And so of all the species that we're going to cover today, this is the only one that I really, really recommend tilapia as a true option for control. Tilapia love this stuff, and as a matter of fact, because it's high in protein and they eat it so well, many third world and developing countries have communal tilapia ponds, and what they do is they have these acres of shallow pits that are only 2 to 4 inches deep, and they grow Azolla on it. And what they do is they skim the surface every so often and push it up and spread it out on the land, and they dry it out. And once it's dried out, it's stable for a long time, and that's their tilapia feed for the entire year. So tilapia can actually get this species under control. Now, if you're not looking to stock tilapia in your pond, our other control options are carfentrazone, diquat, fluoridone, flumioxazine, and phenoxylone. Diquat is going to be your lowest cost option. It is a contact herbicide, and so you do have to hit each and every single one of these plants. However, their reproductive rate is not extremely fast, so you can knock a lot of them back, and even if you miss some, it takes a long, long time for them to become problematic again in most situations. This next plant is giant salvinia. You might have heard quite a bit about this in the news. This is a very, 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 very bad plant. It is a non-native species that has invaded many Texas waters, and it is in fact spreading. Now, let me see if I can do my arrow here. And so you'll see the unique growth structure of it. This is a species that reproduces and has absolutely no sexual reproduction. It's all asexual cloning. And so typically what we'll see is this growth pattern where if you look at my arrow, you'll see that was likely the parent plant. And so what it does is it clones itself to each side, and each one of those clone themselves to each side, and they clone themselves to each side, and you get this growing in a row type fashion. And then what happens is the original parent plant is now squeezed for space, And so basically what it does is it clones itself sideways. And so now if you look at the arrow, it's pointing to this kind of sideways plant, and that's a clone of this mother plant. And then that plant begins to clone itself and make a whole new row. So a lot of times you see these growing in row fashions. Now, some of the amazing things about giant Salvinia is this pond, for example, was clear about 6 weeks prior to this photo. The gentleman sitting out there looking very frustrated in the boat is actually an applicator going out and attempting to apply herbicide. And the reason why he's looking so frustrated is because the vegetation is just so thick that he can't keep the outboard motor running through it. And so it keeps speeding up and shutting the motor down. This is a species that, or Salvinia is a species that can double in size every 4 to 10 days, has absolutely no sexual reproduction, and it can grow in layers up to 3 feet deep. I actually have photos of, well, a standard cinder block typically weighs between 32 and 33 pounds. I actually have photos of 3 of these cinder blocks stacked on top of each other on top of a mat in a pond, and they're barely even making a dip. So this stuff can grow extremely thick, extremely quickly. Now, the issue is, as we look at this oxygen meter, as this plant species basically grows and forms a dome over the top of your pond, there's no oxygen transfer occurring anymore with the surface. And so we look at this oxygen meter, and it's going down below these plants, and it's got a reading of 0.14 milligrams per liter for oxygen. Well, most fish in our ponds require a minimum of 4 parts per million oxygen in order to survive. So this is everything in this pond that requires oxygen was dead long ago. There's no fish or other aquatic life in here. And so that's part of the reason why this species is so problematic. Now, if you find this species on your pond, you're typically looking at Floridone, Pinoxylum, Flumioxazine, or Mazamox. And because it grows so thick, you're typically looking at multiple treatments. You have to come in and apply over the top, kill the vegetation that the herbicide comes in contact with, and then wait for that to kind of die back, and then kill the layer below that, and then it might take up to 3 or 4 times before you actually get back down to the water. So we recommend that as soon as you see this species, you begin treatment and don't let it get out of hand to the point where you may have to make multiple herbicide treatments. Floridone in general is pretty good, but we do like to use the contact herbicide flumioxazine. But once again, the issue with the contact is it's not going to get all the plants, and anything that's missed, it's going to come back. A little bit cheaper systemic that perhaps works even better than Floridone in this case is a Mazamox. It does translocate throughout the plant, so you get a total plant kill, and it is, typically around half the price, if not less than half the price of Floridone, and you get a very effective kill with it. This next species, unless you are along the coastal bend or deep South Texas, you're unlikely to run into this species. This particular species is water lettuce. It kind of looks like, many people describe the leaves as looking like fuzzy tongues. So they are hairy. They have those parallel flowing veins that you can see in the leaf, and they form these little floating like lettuce heads, and that's why it gets the name water lettuce. Now the reason we have this is because it is actually food that's popular in Asian cuisine, and so it used to be imported quite frequently, and at some point someone decided that they shouldn't have to pay for it, so they would just throw some into the local river, and it would propagate itself. And now we have many waterways down in the Houston area that are completely choked off with this species. The reason why most of you won't have to worry about it is because it is a warm weather species, and so if you live in an area where you get at least one hard frost a year, it will knock the plant back, and so it doesn't tend to become problematic anywhere other than South Texas. Now, if you do end up having this species, the effective herbicide formulations are diquat, carfentrazone, flumioxazine, imazapyr, or pinoxylum. We typically go with diquat because it is very effective and it's the lowest cost option. And so typically you won't need to use anything other than diquat. Water hyacinth. There should be two things about this photo that jump out immediately to you. The first is the pretty purple flowers, which is why we have this mess. It was imported as a ornamental species. The second thing that should jump out to you is if you look in the background, that's actually the pond bank going down. You don't see any water in this pond because it's all been evaporated. Water hyacinth is extremely water consumptive. I have lots of photos of dry ponds with water hyacinth in it. Water hyacinth can increase water loss between 200 and 300%. Now, the thing is, most counties in Texas have lose between 50 and 60 inches of evaporation per year. And so if you have 60 inches of evaporation a year, that's 5 feet. If you have a pond that becomes covered with water hyacinth and it's only 10 foot deep, well, you no longer have a pond come the middle of summer because it's going to evaporate that much water. So if we do end up with water hyacinth, we're going to use diquat, imazamox, imazapyr, pinoxylum, or this is the one species that we do recommend manual removal. In order to manage the plant through manual removal, it is quite labor intensive and difficult, and you have to make sure that you get every single bulb of the species out, because if you leave just one, it will multiply back to its former state. And so it's difficult in anything but our smaller, often ornamental or ponds less than 10th acre. Now, in terms of our herbicides, we typically recommend diquat. Diquat in the past has been extremely effective on water hyacinth, and because it is so low cost, that's a frequent option we like to go with. Recently, we have been finding that perhaps some of the plants are developing a little bit of resistance to diquat, and so therefore we're using a lot more imazamox and imazapyr, because those are systemics. They are very effective, and they're not near as expensive as pinoxylum is. So our submerged plants, we actually, here's just a partial list. We actually have many, many more submerged plants in the state. Just wanted to throw up a list real quick, but let's delve into some of the more common species that we have issues with. And so I'm going to start off by saying submerged plants can be very confusing. There are many of them that look very similar, and it can be difficult to tell even if you're trained to identify these, that even if you have them side by side, sometimes it's still very difficult. So for example, here we have 3 species, Aegeria in the top left, Hydrilla, and then Elodea. Agaria and Hydrilla are invasive species, but Elodea is a native species. They all look very similar. Now, if you have a control issue or a management issue with these and they're taking over a pond, the first thing you should know is do not rake or cut. These species reproduce by fragmentation. So if you're breaking that plant apart and not getting every single leaf out of the water, you're actually making the problem worse. You're actually making more and more plants. And so we don't recommend any type of manual removal. Now, the reason why I've got these 4 herbicides listed down below is I've chosen these specifically because it works on all 3 of these species that look similar. So if you're unsure which one of these species you have, use diquat, indethol, fluoridone, or pinoxalone. It kills all 3 species quite effectively. Typically, we're going to use diquat because, again, it's the lowest cost treatment option. Now we're getting into these species. Grass carp are typically only really effective on submerged species, and grass carp are rated as excellent for control of all 3 of these species. So you can stop grass carp to control it. One important thing to remember about grass carp is you're not going to see control during the first year. It typically takes 2 years or more. And the reason why is because you're only allowed to stock 10 per acre. And so there can be 8 to 14 tons of aquatic vegetation per acre. And so if you throw 10 of these little 1-pound fish in there, it's not realistic to expect that they can eat 8 to 14 tons of vegetation. So what happens is, as the plants die back during the winter, the grass carp continue to graze them down, and then during the spring, when the plants are beginning to resprout and regrow, the grass carp are grazing off that new growth before it can become 8 to 14 tons of vegetation. The other option is to use an integrated management strategy. If you want control with grass carp, but you want immediate control, then you go ahead and go out and you do a main treatment with diquat, knock most of the biomass back, and then stock your grass carp, and they will begin grazing off the new vegetation as it sprouts. All right. If you're one of those people that just really has to know what you're treating, the simplest way is by the line drawings. If you break the stem and look down on the leaf whorl, Hydrilla is going to have on average 5 leaves per whorl, and they're going to be straight. Elodea, which is our native, is going to have 3 leaves per whorl on average, and they're going to be hooked. And then Agaria is going to have 4 leaflets on average, and they're going to be hooked. But like I said, if you're unsure, just use diquat, indethol, fluoridone, pinoxalone, or grass carp. And as we'll see in this next photo, even in hand, they can be difficult to tell apart. I think that I'm going to make this my last species so that I can get to some questions. I do want to cover this species real quick, though, because it is one of the most common plant species in Texas. This is a coontail. It is a native species. Another name for it is hornwort, and the reason it gets its name is if you look at it, especially if you look up here in the upper left, you can kind of see the outline against this gentleman's hand, that it has a row of little horn-like projections on the outside of every leaflet. And so those become important later on when we talk about management. The reason it gets the name coontail is because it does look kind of like a bushy or wet raccoon's tail. And other key identification features of this species are you're going to see that it has these unique seeds. They are disc-shaped, and they will have 3 projections or spines coming off of them. And you can kind of see that a little bit better down here in the line drawing. The other unique feature that you'll see are these fruiting bodies, these kind of pink that look like berries. That is another unique feature. So if you see any of these, the little horny projections, the seeds with three equally spaced spikes off them, or these fruiting bodies, you know you have coontail. Now, if you want to treat coontail, the effective herbicides are diquat, indethol, floridone, or flumioxazine. Again, diquat's going to be your lowest cost option. And now, coontail is a species that probably could have been lumped with those 4 species on the previous side, but the reason I do not lump it in with them is because the grass carp. Grass carp are only rated as fair to good for control of this species. And when you think about it, it's those little horn-like projections. You wouldn't like it very much if you had to constantly eat food that had these little horny spikes on them that were roughing up your throat and your stomach the entire time you're eating it. So grass carp will eat it, but they only begin eating it after there's no other vegetation left in the pond that they want to eat. And so basically you need to really stock grass carp over multiple years and make sure all the other vegetation is gone, which you don't necessarily always want that to happen. And eventually they will start eating the coontail and you can get it under control. And at this point, I will go ahead and stop and see if we'll take some questions real quick. Are you there, Clint? I'm having...
Oh, yes, can you hear me now? Can you hear me now, Todd?
Yeah, I can hear you now.
Okay, sorry, I was talking to myself, still on mute. So it looks like we've got 2 questions that came in, and we still do have some time. So I will jump on those 2, and if you have questions, please send them out. First and foremost, the 2 apps that you mentioned at the beginning of the presentation, are they available for Android as well, or only Apple products?
Only Apple products at this time.
Okay.
The issue is the apps actually cost about $5,000 a piece to produce, and there's no translation between the 2. In other words, when you the programming language that Apple uses is completely different than what Android uses, and so there's no direct relation. And the grant we got to do those was limited to only like $11,000. So in the future, we do want to make apps for Android, but right now they're not available.
Okay. Question about management. How should one approach undesired plants in a river, specifically in the hill country?
Okay. If it is in a flowing body of water, you cannot treat the aquatic vegetation. That water belongs to the state of Texas, and actually even pulling the vegetation is illegal. You actually have to have a permit to remove the vegetation from parks and wildlife, and they're going to be the ones that if you have a real, if you do have a real issue, you can contact Parks and Wildlife, and they have a very limited treatment budget, but if they agree it's an issue, they would be the ones that come out and spray. You're not allowed to apply on your own.
Okay. We've had 2 questions that just popped up that are similar. I'll address one side of it, but you may have something to expand on. It says, can we get a copy of the presentation, including your comments to the slides, and do you have a video copy on your website that I can replay? So part of that, the answer is we have been recording this presentation, and we will post it up on our web page and also on our YouTube. I'll grab a link for that here real quick for you. And then, Todd, I'll let you answer if you have a version of this anywhere else that people can go watch.
I suggest you actually grab it from the TWA website so that you can hear my comments, because I don't have a presentation anywhere where the comments are included. So TWA is your best source to get both information. Now, on the other hand, if you would like a copy of the presentation, I don't mind sharing those at all. And so if you just email me at todd.sink@tanu.edu, I'd be more than happy to email you a copy of the presentation.
Okay. The photo or the picture that you're up on now, the coontail, was there another common name for that as well?
Coontail or hornwort.
Hornwort. Okay.
Hornwort's perhaps a more proper name, but it's not as commonly used as coontail. Coontail is the name generally associated with the species.
Okay. Looks like that's all the questions we have right now. I want to post up another link for everyone. The link that I'm adding there now is the schedule for the rest of the Wildlife for Lunch webinars this month. This one was the only one that's not going to be on the third Thursday of the month, but both Todd and I had prior arrangements last week, so we could not do it then. The next webinar is going to be on pollinators and plants and how they're intertwined together. The email and the chat window, I'll post it up there as well. It's todd.sink@tamu.edu. Posted that up there in the chat window and the question and answer panel. Yeah. I would also like to mention, for those of you who are still on, I should have mentioned this earlier, we're doing something a little different this year to encourage responses to our survey. If you do take the time to fill out our survey, you will be entered in for a drawing at the end of the year for a dove hunt for two at Paloma Pachanga, and that will actually be the 2018 season. We have to go through this year, through December before we draw, and a Yeti cougar. So just a little incentive to help us out with some of the information. It's very valuable for us, and it helps us to make better webinars in the future. So with that, I don't see any additional questions. Todd, do you have anything else before we sign off?
Yeah, Clint, I would like to add that if people do want to go to the TWA website and view the webinars, that I have done several of these in the past on aquatic vegetation management that have covered different species and different aspects of management and ecology, and so all those are also available through your website.
Yes, I appreciate you mentioning that. There's a lot of other webinars, and let me, let's see. If you scroll up in the chat window, you'll see that link. Let me just grab it. Let me grab it and post it again for you all so that you have it. So if you go check out that link, you'll find this as of, say, next week, and all of our other webinars that you can go back and watch. Let's see. Oh, this is a good question that just came in. As a sheep breeder, I have to watch copper poisoning. If copper-based herbicides are used in a pond, is there a residual effect?
Okay, so the label for copper sulfate and chelated copper algicides actually has zero use restrictions when it comes to watering livestock. In other words, you can use it and livestock should be fine to drink it right away. However, my parents raise sheep for a living, and with that, makes me a little bit leery, knowing the negative repercussions that copper can have on sheep. And so what I typically recommend is if you're going to use a copper-based algicide, make sure to keep your sheep from being able to water from that body of water for a minimum of 8 hours. By 8 hours, even chelated copper complexes should be precipitated to the bottom where they're found in the sediment. So in other words, no, there is no restriction, but I'm leery myself.
Perfect. Looks like that's all we have. I'd like to thank everybody for tuning in. Thank you, Todd, for your time, for the great presentation. And once again, if y'all would like to go back and watch the other webinars, please hold on to that link. I'll leave it up after we both sign off. So I think that's all we have. And Todd, we'll talk to you soon.
Sure thing. Thanks.
Yes, sir.